welcome back to another video of H&H Express model and scale trains.
So on Wednesday night, in the Technology as a Tool Not an Obstacle series from Heath from Humanity Junction, see link here in the top right corner, Heath talked about controlling an automatic shelf layout and using a motorman to do that. I built the same setup but then with an Arduino, and you can use any Arduino you like. You can use a Arduino Nano, a Arduino Uno, an Arduino Mega, any type of Arduino which has digital pins. I'm using two infrared sensors. They are connected to the Mega, and I use a motor shield to control the power on the track. And the power is coming from a transformer, which is a DC transformer from my track itself. So as you can see, when the train moves to the left infrared sensor, it detects the train and the polarity is changed and it moves to the right. And this keeps on doing constantly. And you can actually control the speed as well via sending a PWM signal to the motor shield, but you don't have to do that. I'm doing that in this situation because my reverse is faster of this train than the forward motion. So let me show you how I did that, and I will show you that in a small video how everything is connected, and then later we will dive into that sketch which I built. So let's see how everything is connected. We have the track, we have an Arduino, can be anything, Arduino Uno, Nano or Mega. We have the infrared sensor 1 on the left. We have the infrared sensor 2 on the right. We have a motor driver, the L298N. They're all connected to the 5V from the Arduino. On the motor driver we have disabled the internal power jumper. Sensor 1 is connected to pin 9 and sensor 2 to pin 8. The track power is connected to the output of the motor driver. We have pin 42 connected to IN2. Pin 43 is connected to IN1. And pin 44 is connected to the ANA. And then we have a separate power connected to the motor driver. So as seen in the diagram, infrared sensor 1 is connected to pin 9. So I have defined the IR sensor _1, which represents number 9. IR sensor number 2, which represents number 8. We have the L298N input 1 is connected to 43 and input 2 is connected to 42, and the enable for A, that's one side of the motor driver, is connected to pin 44. To avoid any duplicate information or duplicate detections, I created a boolean that the infrared sensor was detected, and it is set to false by default. And another boolean that is the movement of the train. So the train moves to the right equals true, that's a boolean. That means that at the start of the program the train will travel to the right, so that the right infrared sensor, which is the infrared sensor 2, if that one is detected, it travels to the left. And then if the sensor 1, which is on the left, is detected, it travels back to the right. In the setup, we do a serial print, that is the output which you saw in the beginning, where it says auto reverse the train on a straight track. At start of the program, the train moves to the right. The infrared sensors are connected to a digital pin. You can also connect them to an analog pin, but I use a digital pin because that is easier to read. Otherwise you need to create analog values and calculate what value is needed to get a high or a low signal. So the pin mode for infrared sensor 1 and 2 are both inputs, digital inputs. All 3 pins connected to the motor driver are outputs, and we are setting the output value, which means IN1 is set to high and IN2 is set to low, and the enable pin is set to high, which means full power. Because this is a PWM pin, you can also do an analog write to it, as mentioned here. And the 255 is the maximum value what you can write with an analog write to a PWM pin, which means it's fully high. And that is 100%. 127 is 50% of the load, and 63 is 25% of the speed of the train. So, and then we have a loop. So this is the whole loop, and what I do is I read the invert of the infrared sensor, because the infrared sensor, if it's high, then it means there is no output detected. If it's low, that means that there is an output detected. That is something what you need to check with your infrared sensor what you have. In my case is when it's low, that means it detects a signal. So here in the loop, the first check is the invert of the infrared sensor. And I also check the IR sensor detect. I put an exclamation mark in front of it, which means it inverts it. So if the IR sensor has not been yet detected, then this is true. And if the train is not moving to the right, then this is also true. That means that the train was traveling to the left. Then I'm checking, okay, the left side track is detected. Reverse polarity of the track, it will be displayed and the train will move to the right. What I need to do is I need to invert the IR sensor 1 detect, which is done in this line. And I need to reverse the direction of the train. Actually, the boolean is then set, the train moves to the right, will be the invert of the current status. I'm gonna set IN1 to high and IN2 to low, which means it is traveling to the right. And I set the maximum speed to 255. I could also do a digital write high to that pin. If this is not the case, then the infrared sensor 1 was not detected, so I'm gonna put that to false. The same counts for sensor 2, which is the right sensor. If it is being detected, and it says here it's the invert, because that's what I just explained for this sensor. So if this one is true and the train indeed moved to the right, then I'm gonna revert it so that the train moves to the left. I'm gonna use the infrared sensor 2. I'm gonna put an invert here so that if it has been detected and it's still detecting, then it doesn't constantly do this loop. The train moves then to the right, which means I need to invert the train movement. And then I'm gonna set the pins on the motor driver, IN1 to low and IN2 to high, which means it reverses the polarity on the motor driver and on the track. And I'm gonna set a new speed. Since my locomotive which I'm using has a forward motion which is slower than a backward motion, I'm adapting the speed for the backward motion to 190 cycles. So that is approximately 65%. If this is not the case, then I will set the infrared sensor to false again. Within this loop, to avoid too many entries and too many detections, I put a delay in it for half a second. So this loop takes roughly half a second to run before it reads the sensor again. In your situation it might be lower, but I'm doing this on purpose so that I don't receive multiple reads, and it makes it easier. So with this said, you saw in the beginning what the train does. It moves up and back, so it moves to the right, detects by sensor at the right, then it moves back, and that's the whole loop. So this is actually a very small sketch which is used to do an auto reverse on a straight track for a train, and that a motorman does actually the same. So let me run the train again. Let me start the program so you can see that it also says auto reverse the train on a straight track. At start of the program it moves to the right. Let me put power on the track. Here he goes. It's been detected, goes to the reverse. It's been detected by the other one, and it reverses again. So I hope you like this one. Please leave comments below if you have any questions in regards to this, and I will see you in a next video. Thank you and goodbye.